In the last video, you learned about real interest rates and the loanable funds market and how the supply and demand and the relationship between borrowers and savers affects real interest rates. Now we're going to briefly revisit nominal interest rates and that relationship between nominal interest rates and real interest rates. So what exactly are nominal interest rates? Nominal interest rates are rates that build in inflation or include inflation. Remember, inflation is taken out when we come up with a real variable or a real number. But nominal variables include inflation. So as it says here, nominal interest rates build in inflation. They also take into account a number of other things like risk, maturity, loan size, etc., like we talked about in the last video. But the key difference here is this piece about inflation. So the equation that we've been using basically all semester is that nominal minus the rate of inflation gives us real, right, when it comes to interest rates. We're going to add a little bit to that equation, make it a little bit more complicated. So this equation is actually called the Fisher equation. It's named after an economist at the University of Chicago. And in this equation, we have the nominal interest rate, which is the rate, for example, that the bank pays you on your savings account or the rate you pay on a loan. And we have the actual real interest rate, which is this, nominal minus inflation equals real. And then we have this other piece, the expected real interest rate. And the expected real interest rate is calculated based on expected inflation. The expected interest rate is the amount you would need to receive in real terms in order to give up or forego your consumption now for consumption in the future. So think back to when we talked about present value. We adjust, how much would we need to pay you a year from now to make it worth your while to wait to get your money until a year from now. So would you need a 10% return in order to be willing to save your money? Would you only need a 5% return? Would you need 20%? What is the expected real interest rate that you would demand in order to be willing to save your money? So when banks set their interest rates for borrowers, they set them based on their expected real interest rate. And they calculate that. They say we want an expected return of, say, 3%. Okay? In order for us to be willing to lend this money to this person, we have to know we're going to get at least 3% more back, say, a year from now. And then they calculate the expected inflation rate. And I know this is a little bit odd, right? Because we're using pi, right? Pi in the Fisher equation equals inflation rate. I don't expect you to necessarily use that abbreviation, and you don't have to use it on the AP test. You can always say inflation rate or inflation percent, but you do need to recognize it as the inflation rate. So if you see it in an equation, that's what it means. So I want 3%. And it looks like right now inflation's probably going to be about 5% over the next year. So when someone comes to the bank to borrow money, I say, okay, well, I want 3%. There's going to be inflation of 5%. I'm going to charge you 8%. So that's how nominal interest rates are set. Banks calculate their expected minimum return and they estimate the inflation rate and they set the nominal rate. So that's where we get the nominal rate from. But, as it says down here, the real interest rate the banks earn will be different than their expected rate if inflation ends up being different. So, let's say we followed through this equation and we've made a loan to a reliable borrower at 8% nominal interest rate. This was based on a predicted inflation rate of 5%. But now, let's say inflation surprisingly rises to 7%. Okay, so real inflation is 7%. Now, at the end of that year, what is the bank's real return? It's not the 3% they wanted, it's 8% minus the 7%. Bank's only getting 1%. This is why lenders lose when there's unexpected inflation. Remember, we talked about that pretty early on in Unit 2. If there's unexpected inflation, it hurts lenders. It helps the borrowers. They don't feel that helped, right? Because they're like, we're still paying our 8% nominal rate, but you're actually only paying 1% interest now instead of 3%. So this is a little more technical explanation of why it is that inflation hurts borrowers and hurts lenders and helps borrowers. And keep in mind, that's unexpected inflation. If inflation turns out to be exactly what we expected it to be, the lender isn't hurt at all, right? If it ends up being 5%, they get the 3% they wanted, and they're fine. And it's neutral also for the borrowers. So this equation and this effect leads to something called the Fisher hypothesis. And this is that increases in inflation will result in increases in the nominal interest rate, right? Because think back to this. If there's 7% inflation, now the next time I make a loan, what am I going to do? Am I going to be willing to lend to somebody else at 8%? No. Now I'm going to say, that's not the inflation rate I expect anymore. Now I expect 7%. So the new nominal interest rate will be 10%. Right? So the lender will update as forecasts about inflation change. If they expect inflation to come down, then nominal interest rates will come down. So increases in inflation will result in increases in the nominal interest rate or decreases in the real interest rate, right? At least in the short run, or a combination. But the evidence of studying this over time is that increases in inflation tend to lead to increases in nominal interest rates in the long run. They do not lead to decreases in the real interest rate. So what does this mean for us and our monetary policy? It means that if we increase the money supply in the short run, it will decrease nominal and real interest rates, right? Because if we increase the money supply in the short run, now I'm calling on you to pull together a lot of different pieces of information. This is the money market, right? If we increase the money supply in the short run, we can see from our handy money market graph, nominal interest rates fall. Similarly, in the loanable funds market, that increase will lead to increased bank reserves and real interest rates will fall. But in the long run, because these increases in the money supply increase the price level, they will end up increasing nominal interest rates. So in the long run, rather than saying, oh, there's more money out there, let's lower interest rates, the banks are going to say, oh, there's inflation out there, we need to raise nominal interest rates. So short run, you can have this desired monetary policy impact on interest rates. In the long run, not so effective. And real interest rates in the long run, kind of like the natural rate of unemployment, real interest rates tend to gravitate back toward the same amount, whatever that minimum expected rate of return is that banks want, probably somewhere around 3 to 5%. So you might want to replay this video and just make sure that you're really, really solid on this relationship between how banks set nominal interest rates using expected inflation and then how real interest rates are calculated later based on actual inflation.